Let's look at the binomial theorem today. I'm kind of treating this like you have already done this in college algebra, and so this is kind of a refresher for you. The binomial theorem is what helps us take a binomial like a plus b and take it to a power without having to FOIL it out a whole bunch of times. By using the binomial theorem, and this is it in a nutshell, it's the sum. This is a fancy summation notation of a whole bunch of different terms. And these different terms that we're finding the sum of is this right here. It's the combination of whatever your power is, and then this is a summation notation. It starts off at 0 and it works its way up to n. So it's going to be n choose 0, then n choose 1, n choose 2, n choose 3, all the way up to my power. For your variables, so you would take this first term and you're going to raise it to a power, and then you're going to take the b and you're going to raise it to a different power. Now, this is a nice fancy summation notation that your book uses, and we're actually going to learn this fancy summation notation in this chapter. Let's break it down a little bit more. Again, I've got my a plus b to some power. I have to take the combination. This is the number that we actually ended up getting from Pascal's triangle. And then you're going to take your first term to the highest possible power. Notice that it's to the nth power because that's what power I'm taking the binomial to. And I'll start off with my second number to the very lowest power. It will always start off at 0. And then I'm going to add, and I'm going to start over, and I'm going to do another combination of n, so whatever that power is, choose 1, a to the, now we're going to take our power and we're going to drop it 1 power. So if this was being taken to the 10th, now this was to the 10th, this is to the 9th, this will be to the 8th, and so forth. This works its way down each time, whereas the b exponent works its way up. Do you see where it was a 0? Now it's a 1, then it's a 2. Okay, let's try this with some real numbers. Before we do that, though, we do need to remember Pascal's triangle because it's an important part of what we do in the binomial theorem. Recall that that Pascal's triangle starts at the top with a 1. And actually, let me backtrack here. Really, I'm going to squeeze this in over here. This starts off, and what Pascal's triangle really is a representation of all the possible combinations. If you took 0, choose 0. Or maybe you had 1, choose 0. Or 1, choose 1. Or maybe you had 2 things and you did 2, choose 0. Or 2, choose 1. Or 2, choose 2. Or 3 things, choose 0. 3, choose 1. 3, choose 2. 3, choose 3. And so forth. And if you went and calculated all of those, you would end up with Pascal's triangle that looks like this. It has a 1, then a 1 and a 1, and then a 1, 2, 1, 1, 3, 3, 1. Recall from college algebra that this number is really just the sum of the 2 above it. 2 is the sum of 1 and 1. 3 is the sum of 2 and 1. And the edges are always 1s. So to get my next row, it's going to be a 1. And then I'm going to take 1 and 3. So this is going to have to be a 4. 3 and 3 is a 6. 3 and 1 is a 4. And then it ends in a 1. And you can keep going and build that in your notes for as far as you can before you start running out of space. Okay, now we're going to come back and we're going to use that Pascal's triangle as we do the binomial theorem. Here we have a couple examples. I'm going to start off with an a plus 3, and I'm going to raise it to the 5th power. Now remember that this right here is kind of what we're doing here. Every time you're going to have 3 things going on, and then you're going to be adding those over and over and over. So my first thing is my combination number. That's my number from Pascal's triangle. That's my Pascal number. And it depends on what power it's being raised to, on what Pascal number I'm going to use. This first example, I'm raising it to the 5th power. So go back and look at that previous slide and pay attention to what the 5th row. Remember, it starts off at the 0 row. So the 5th row is going to be the one with all the 5s in it. That row goes 1, 5, 10, 10, 5, 1. All right, I'm going to use those numbers and place them in right here for the combination. I'm going to start off, you're going to need to write little on this, and I'm going to take my combination number, which from Pascal's triangle is a 1. I'm going to take my a to the very highest power, so in this case it's to the 5th, and then I'm going to take it times 3 to the lowest power, which is going to start off at 0, plus. And then we do it again, and we grab the next Pascal number, so that's a 5. And then I'm going to write my a, and its power is going to drop, so now it's to the 4th. And then I take the 3, and its power is going to go up. It was to the 0, now I'm going to put it to the 1st power. And you just continue this process, plus. The next Pascal number is a 10. My a is going to work its way down, so it's to the 3rd. My b value, which is 3, is going to work its way up. Plus, the next Pascal number is another 10. So I'll have a 10. A works its way down. The b value works its way up. Plus, next Pascal number is a 5. A is going to be to the 1st. The 3 is going to be to the 4th. Plus, last term it's going to be a 1. My a is going to be to the 0, and my 3 is going to be to the 5th. Whoops. Now, that's your first line, but then you have to condense it and simplify the stuff up so that the term looks nice and clean. This term right here has a 1. As far as the coefficient part of it, or the number part, is going to have a 1 and a 3 to the 0. And 3 to the 0 is 1. Times this 1, these are all being multiplied. That's just going to end up 1a to the 5th, or a to the 5th power. Plus, here's my next term. I have a 5 and I have a 3 to the 1st. I'm multiplying. That's going to be a 15. A to the 4th power. Plus 10 times a 3 squared, that's 9, so 90. A to the 3rd. Plus 10 times 3 to the 3rd, that's 27, so 270 a squared, plus 5 times 3 to the 4th. 3 to the 4th is 81, times 5 is 405. A, plus, and our very last term has a 1, it has a 3 to the 5th, but it has this a to the 0. A to the 0 is just 1, so the variable part actually drops off at this point, and my 3 to the 5th power is just 243. And that's your final answer right there. That's what you would have gotten if you would have sat there and foiled this out 5 times and never made a mistake. This is much less likely for you to goof up on, to do binomial theorem, than to foil that out a bunch of times. Let's try one more example like this. It's a little, I threw a bunch of messy stuff in it. This is kind of your basic problem. This is way messier. Notice that my front term has a coefficient on it this time. Notice that it's now subtraction. Notice that my second term is now squared. This right here is the reason this first level of work is so important. Now I did keep it a little bit lower. It's only going to be raised to the 3rd power. That means I'm going to be paying attention to my 3rd row of Pascal's triangle. And remember that that's the 3rd row is the one with the 3's in it, so it's going to go 1, 3, 3, 1. Now, using our pattern, using our formula right here, it's going to be the sum of 4 separate terms, it looks like this time, and I start with my Pascal number. The first Pascal number is a 3. is a 1, so I put a 1, and then I'm going to take my a value, which is 2x, I'm going to raise it to the highest power, which, since I'm taking it to the third, is 3. And then my second term is actually a negative y squared. That's going to be the weird part on this problem. And it starts off to the 0. Plus, we go to the next term. The next Pascal number is a 3. And then you're going to have a 2x, and it's going to work its way down, so now it's squared, while the negative y squared works its way up, so now it's to the first. Plus, next Pascal number is a 3. My 2x working its way down, while my negative y squared works its way up. One more, the last Pascal number is a 1, and then my 2x is going to end up to the 0 power, while my negative y squared ends up to the third power. Remember the pattern on this, that these two powers should always add up to what your total is, so these should always add to 1, always add to 3, and they did. Up here on this one, since I was taking it to the 5th power, they always added to 5, 4 and 1, 3 and 2, 2 and 3, 1 and 4, and so forth. Just a little pattern to help you make sure that you're on the right track and that you didn't start moving your exponent up when it was supposed to be going down. I tend to do that sometimes. All right, let's clean each of these terms up. Let's start with the number stuff. So I've got a 1. Here is a 2 cubed. That's an 8. That's all of my number stuff. My leading coefficient then is going to be an 8. My x is going to be to the third power, and my y, even though it was squared, it's being taken to the 0 power here, which is going to make it a 1, and this negative is going to go away with that. All of that whole mess is just 1, so that doesn't change anything. My first term is just an 8x cubed. Plus, let's go over here. You have a 3, and you have a 2 squared, so that's 4, that's 12. That's my coefficient part. My x is going to be squared. And then this is where it gets a little tricky. I'm taking this power to a power, so you should be multiplying there. That's going to make my y be y squared. But we have to watch out for that negative right there. This whole term is being taken to the first power, so that's going to stay negative. And when I'm multiplying this positive times this positive times this negative, this whole term is going to end up negative. And the way we typically show that is by making this, instead of a plus sign, that should be a minus sign right there. And my y would be squared. Let's see what happens on the next term. We have our 3 times our 2 to the first, so that's going to get us a 6 for our coefficient. Our x is raised to the first power, so that's just there. And I'm getting a little anxious with my plus sign because that might need to be a negative. Let's check. Right here, for the y part of this, squared, that's going to be to the 4th power. But since I'm taking a negative and I'm squaring it, that's actually going to make this term end up positive. Positive times positive times positive is going to stay positive. That actually does, I'm okay with my plus sign there. But I do need to add in my y to the 4th. Now what do you think is going to happen on my next term? Is it going to end up positive? Should I put a plus sign or should I put a minus sign? Well, look at what happens with your negative. It's now being taken to the 3rd power. That would make that a negative value. I should be putting a minus. And what happens then is anytime that you have a minus sign in your binomial, the signs on your final answer end up alternating. Your first one is positive because that's being taken to the 0. But then when it gets taken to the first power, it'll be negative, and then it'll be positive because it's squared, then it's to the 3rd. So it just goes back and forth. All right. Now, for my number part, it looks like I have a 1 and a 2 to the 0. All of that is just 1. I don't even have a number to write, so I'm not going to bother to write a 1. My x is raised to the 0 power, so it's going to go away as well. The only thing I have left is my y. Power to a power, that'd be a y to the 6th. It is negative. And that, ladies and gentlemen, is my final answer on my binomial theorem. Now, it takes a little bit of work, but really it's faster than trying to FOIL it out, and once you get the hang of it, it moves pretty quickly. Now, because it does take a little bit of time, I can't ask you to do 5 or 6 of those on your test, but I can ask you other parts about that process and see if you can figure it out. So perhaps I don't need the whole polynomial. I just want to check one single term out of your whole polynomial. You won't have time, nor do I want you to take the time anyway, to find the whole polynomial if I just want one term. So in this example, it says find the coefficient. So all I want is the coefficient of the x to the 4th term in this whole mess. Okay, we're looking for a pattern here of when would that x to the 4th occur. So let's think about this for a second. I'm going to find my very first term, I would take the Pascal number, which remember came from the combinations of whatever power that is, because that's what row I'd be pulling from. And the very first time it's a choose 0. And that always is a 1, anytime you choose 1. So that first Pascal number was always a 1, but it came from this 7 choose 0 thing. And then I'm going to multiply it times 5 to some power, I'm not sure what yet, times 2 to some power, I'm not sure what yet. Oh, sorry, that should be a 5x to some power. Okay. Now when I look at this then, a couple things I need to remember. Since I'm looking for the x to the 4th term, that should clue you in right here what you should be raising that to. That should be raised to the 4th. That's how you're going to get your x to be 4th. The other thing that I need you to notice is remember that little trick, what I told you about what should always happen with these two powers here. Well, they should always add up to what the big power that you were shooting for. If that's to the 4th, then that better be to the 3rd power. I'm going to put a little 3 there then. All right, I'm getting there. Now here's the problem I have though. This little 0 that I put in, that's not right. That's for the very first term. This is not going to end up being the very first term. Remember that when we started off, we'd put our Pascal number. This would be the highest, this would be the lowest. Well, we've done a few terms. This is not the very first term. It's like there's been some before this, and there will be some after this. But if this was a 7 choose 0 on the very first term, remember this is your high power, so that would have been a 7th power, and that would have been a 0 power right there. This power here will always match what that is, because this increments 1 space each time, just like this is incrementing up 1 each time. So if I put a 3 here, what that means is this would have been a 7 choose 3, and that's the Pascal number I would have used. Let's go ahead and calculate this then. So in your calculator, assuming you have a TI-84, remember to get your combination stuff. You go to your math menu, but first I'm going to press 7, and then I'm going to press my math menu, and then I'm going to go over to probability, and number 3 is my combinations. So it's going to be 7 choose 3, and I got a 35. So this is going to end up getting me a 35 times, and then I'm going to have a 5 to the 4th power. That's a 625 x to the 4th. And then the next term is 2 to the 3rd. That one I can do in my head is just 8. And then I would multiply all of those together. Now notice that it does say that it only wants the coefficient, so I really don't have to have this x to the 4th in the problem. I'm just going to take my 35 times 625 times 8. So in my calculator, 35 times 625 times 8. And so the coefficient on the x to the 4th term is going to end up being 175,000. That's my answer. That's all I got to do. Now let's, for the sake of our notes, kind of write a little bit about what we figured out right here. And I don't know that I have a great place to write this, so I'm going to write it up here. But it's always going to be the combination of, well, you know what? Here's what I'm going to do. I'm going to use this example that I have. I think that might be as easy as anything. I just need to remember that these two, so let's use this to kind of as our notes. Those two have to add up to that. Their sum is going to be that power that we've got. And this one will always match that one. That's really all there is to it. Let's try this next example and see if we can use that pattern without even having to think through it. Pretty much once you got it, you got it. So it's going to be the combination of the highest power is a 10, so it's going to be a 10. Choose, not sure yet, I'm not going to put anything there yet, times, the first term is a 2x, and the second term is a negative 3y. The directions say that I want the coefficient of the, oh, this is fancy. See how there's two variables in this one? They want me to have the coefficient of the x to the third, y to the 7th. That means they want my x to be to the third and my y to be to the 7th. That's actually easier because do you see how these just naturally add up to the 10 that they're supposed to? That will always have to be the case. Those two would match up that way. Just because there's two variables doesn't really make it harder, kind of makes it easier. All right, the other thing that I need to know though is it's 10 choose what? And remember that this matches that, so it must be 10 choose 7. So I go to my calculator and I type in 10 math probability number 3 choose 7. All right, that's a 120. And I'm doing this kind of to write it out, but really you could kind of just do this in your calculator. I mean, I want to see this part. I want to see you set this up so I know that what numbers are going where. But once you got your 10 choose 7, you got your 120, you're going to be taking that times a 2 to the third times a, be careful, times a negative 3 to the 7th. That's going to end up a negative number there. So when I multiply this all out, looks like I'm going to end up with a negative 2099520. These coefficients are typically going to be huge. I'm going to purposely make this an obnoxious one that you're not going to want to do the whole thing just to pick out one term. This would have a whole bunch of terms you'd have to do if you were going to do the whole thing. And that's why the coefficients get so large. Don't freak out if you get a big coefficient. That's fine. All right. Why don't you give this lesson a shot?